Welcome everyone. The question that is shown on the screen, it is the question number 12 of the CBSE sample paper 2025. If a copper wire is stretched to make a radius by 0.1%, then the percentage change in its resistance is approximately option A is minus 0.4%, option B is plus 0.8%, option C is plus 0.4%, and option D is plus 0.2%. So obviously when the wire is stretched, one thing is kept constant there, that is the volume. So if I say that this is the wire, okay, let us say this is the wire, okay. So if I say this is the radius of the wire, initially this is the radius of the wire, and this is the length of the wire, that is the L1 initially. If you stretch it, if you are able to stretch it, then what will happen? The radius will decrease, cross section area will decrease, and what will happen? The length will increase. But one thing is there, that is the whatever the matter in it, that is the volume of it, that remains constant. So one thing we can say, the V, what is the volume of the wire, that is constant here. So obviously if the radius increases, if the radius decreases, the length increases, or if the length increases, the radius decreases. So we know this equation very well, okay, that is R equal to rho L divided by A, okay, where A is the cross sectional area. So we can say, just replacing this cross sectional area by pi r square. Now here obviously since V is constant, we can say that it is pi r square multiplied by L equal to constant, okay, and that constant is V obviously, okay. So from here if you want to find it out, what is L, it is V divided by pi r square, okay. So if you just replace this here, rho L I am replacing by pi r square divided by pi r square. So this thing will become rho V divided by pi r to the power 4. Obviously you may ask why I have done this. Because in this equation L is a variable, R is a variable, okay. So I am replacing the L and by in terms of R, such that there will be one variable now. Rho is a constant which is not going to change if you stretch it. Since the materials remains the same, the volume remains the same because no addition of matter is it. So pi is also a constant. So we can say capital R is now proportional to 1 by R to the power 4, okay. So obviously we can say now that R, the resistance, equal to a constant of proportionality divided by 4. Now if I want to calculate what is the percentage change, increase or decrease, then very popular method is take the logarithm. Ln R equal to ln K plus of ln 4, okay. I am writing down minus of ln 4 because it is in the denominator. So obviously it is ln K minus of 4 ln R, property of logarithm. So this is the whole equation. Now if you just differentiate this equation, if you just differentiate this equation, a very important equation will come, that is d capital R divided by R. Since K is a constant, so ln K is also a constant, so it is 0, minus of 4 ln R becomes dr divided by R. So from here the equation what is required, that is the change in resistance dr by R minus of 4 change in radius dr by R, okay. If you want to express this thing in percentage, you can write it down, that is dr by R in percentage equal to minus of 4 dr divided by R in percentage. So what is the value of dr by R? Because it is said radius is decreased by 0.1%. Okay, radius is decreased by 0.1%, so we can say dr by R equal to minus 0.1%. Radius is decreased by, so minus 0.1%. So obviously if you find it out, what is dr by R in percent? Nothing but it is the substituting the value in this equation. So it will become minus of 4, dr by R is minus of 0.1%. So this will become plus 0.4%. So here obviously the percentage change in resistance is approximately plus 0.4%. Okay, thank you all of you.